Okay, we've been looking at the graphs of sine and cos primarily for the last few days. We're going to now start sketching our own. So looking at this one here, what I know from before, the amplitude is based on the value out front here. So it's going to be a value of 3. We have 4 full cycles of the curve in a distance of 2 pi based on this one here. And we haven't maybe discussed this entirely, but it's a pretty obvious thing. Whatever I had before, whatever this works out to be as a y value, I'm going to decrease by 2. So the minus 2 on the end just takes my whole graph down 2 spots. So one of the questions we've run into a few times now is what is the period based on this? And the period is the 2 pi. Sorry, by definition, let's say that the period is the distance of one cycle. And so essentially though that 2 pi distance is divided into 4 parts. And so the period is, of course, pi over 2. Now that doesn't really matter a lot in this question. I know that I have to get 4 cycles into 2 pi, and so that's what I'm going to do. But it will come into play a little bit on other questions. So if I'm looking at this now, my original curve would have gone starting at 0, up through 1, down through pi, to -1, and on to 2 pi. So that's sort of the basic curve. Let's see if I could draw that without too much trouble. Okay, so there's your normal sine curve. In this case, my amplitude is 3, meaning the values that were going to be my original y values will be tripled. So my graph has to come up to 3, back down through 0, and so on. But again, the important part, or another important part, let's say, is this here. I have to get 4 full cycles in that distance of 2 pi. So instead of this, I'm now going to have my graph have to go up, down, and back to this point, up, down, and back to this point. Again, that's the period, so I have to get a full cycle of the curve in that distance of pi over 2. And then again, and again, and again. And so if I look at any one of these sections, the middle of that section, oh, this was poorly done. The middle of that section is right there. The, let's say, quarter point of that section is there, and the quarter point of that section is there. And so that means I have to get all the way up to this 3 right here, back down through the 0, all the way down to the -3 right around there, and then back to the 0. So I shouldn't have marked them quite that way. My intention was to mark them with just sort of little ticks to indicate those are kind of the spots that I'm trying to hit. And so my graph now is going to go up, down, whoa, and back up again. Hard to do with a tablet. Now you'll notice at this point I've ignored the -2. The -2 on the end. And that's because later on, once we get the last of the options in, what we've sort of referred to as the minus C or the plus C in here, it's going to be a little easier if we do it this way. Okay, so we're back. Basically just repeated the pattern out to 2 pi and back to -2 pi. I fixed up the little bit here as to how poorly that was drawn. But you can see that basically all we've got from the first two values again is I'm going up to 3, down to -3, and then I have to squeeze that entire thing into the distance of pi over 2 into the period. At this point, I still haven't dealt with the -2, or sorry, the -2 again on the end. And so all I'm going to do is indicate on the y-axis that each of these values should be 2 lower. And so subtract 2, and so on, to get to the point where I have the correct values in the various locations. And then I'm going to draw in a little bit more nicely where my axes should be. Okay, so the graph paper that you'll have will have a fairly faint indication of where the original axes were, and you'll just make sure that your axes end up looking nice and dark at the end. At this point, this is still the y-axis, and so I'll draw it in nicely like that, and that will be our, you'll call it kind of a rough draft of our graph, although you can see that it is still fairly decent at this point. Slight variation on the question then. You can have something that'll look a little bit different, and just want to kind of cover it before we move on here. Sometimes the k value, or what we've indicated as the k value previously, the coefficient of the angle, will be in terms of pi. In those cases, nothing really changes. My amplitude here is 3, obviously. I'm going to go down 2 from this value over here. What I'm interested in, though, is how many full cycles should I get in the 2 pi? Well, of course, that helps us establish the period. And so last time I said 4 full cycles in 2 pi, didn't really need to know the period, although obviously I did use it. The 4 full cycles told me what I needed to know. Here I actually have pi full cycles in 2 pi, which doesn't make a lot of sense to me. But if we think about what the period is that this 2 pi distance is going to be divided into pi sections, essentially. And so the period then, when we do this division, is just the number 2, or the value 2, which is to say that in a distance of 2, and you see them on my x-axis now, I've simply labeled it with 1s, 2s, and so on. In a distance of 2, I'm going to have 1 full cycle. The rest of the graph remains the same. At this point, my amplitude is 3, so I have to go up to 3 and down to -3, assuming I have room. I do. And I'm going to cover that in a distance of 2 on my graph. And so fairly quickly here, those will be my zeros. I have to go up to the halfway mark to +3, down halfway between these to -3, and my graph will look kind of like this. Can we get there? Not too bad. Of course, that's going to be extended to the other side. Whoops. And then exactly as we did before, I'm decreasing my y values by 2, and so this is 1, 0, -1, and so on, and my new axes are here. And again, at this point, this one hasn't changed. It will eventually. Okay. So just sort of looking at the final graph, then you see that this is what the graph actually looks like. And again, the information is all there. Okay, so we'll go with that today. We'll be doing these for a couple of days. Again, we'll be including that last value eventually, so there'll be a little bit more to do. But I think this is kind of the nicest way to go about drawing these. Figure out the amplitude and the period, get your basic shape in there, and then we'll adjust the axes and draw them in nicely to indicate where the final product is.